So you need to be careful. Okay, if I'm not audible or anything, please you unmute and tell me, because I cannot see the chat box now. I will not go back. Now, next topic what we're discussing is, okay, operating systems and execution environments of WSN. Okay, that is a wireless sensor network. Now, means what? What are we looking into? We are looking into what parameters we need to consider to select an operating system. Okay, and what execution environments we need to have for a WSN, because it is wireless sensor network. We know that what are the limitations, okay, with which, what are the constraints we have while designing the wireless sensor network. Underline the word wireless. Okay, so the main thing was the power. Okay, the design of the battery or the power. So keeping that as the utmost priority, we need to select the operating system as well as the execution environments. Now, energy efficient execution is required, that anybody can think of. Okay, when we talk about the execution, it should be energy efficient. Okay, requires support for the energy management. It should have an appropriate programming model. Okay, a clear way to structure a protocol stack, and explicit support for energy management. These three are the main parameters which you need to consider, okay, while going for the execution environment, without imposing too heavy burden on SCART system resources like memory or execution time or even the battery. So, see, just to balance, to trade off with the energy system, can I directly take the data and send the raw data to the main system? No, I cannot do that. Some cases I can do, but at some cases I cannot do that. Okay, I have to process it over there. The reasons may be different. Okay, some the data collected may be very feeble. Okay, some the data collected has to be encoded or encrypted, so that, okay, it is not hacked. Okay, it is secured. So for different reasons, I may have to process the data at the node itself. So in that case, the programming, okay, has to be stored as well as it has to be executed. So for all these, what comes in my mind? Okay, the energy, the power. So to do whatever it is, okay, we need the power. Okay, if the power sustains, then I can think of designing a system. Okay, having extra memory. Okay, anybody wants to say anything? Okay. Hmm. So all those things I can see. So, but with this constraint, power constraint, okay, we need to see what is the, like, how can I optimize my operating system as well as yeah, operating system and the platform, so that, okay, I get the better result. See, always optimization doesn't mean that going for the best. It is a trade-off. When we go for optimization, everywhere the trade-off will be there. Trade-off is balancing. Okay, balancing for one sake of one parameter, another parameter will have to balance. So that is called as trade-off. Next, coming to network architecture. Okay, so it is introduces basic principles of turning individual sensor nodes into a wireless sensor network. That means what we studied about the sensor nodes now. Okay, now actually we are clubbing that sensor node in the wireless sensor network, because with one node we cannot work. So like that, only different nodes we will be having. So how to club that? When we are clubbing, how actually it performs? What protocol we need to take? We need to adopt. See here, there are different scenarios are there. See, this is the source now. Okay, from source, this is the sink. So direct connection. Yes, anybody, easiest one. Okay, anybody can make out. Now, actually, if you see the second scenario, this is the source. Okay, from this, it is coming to this node. From here, it is coming to the sink. Okay. Yeah, if you ask me, from here, why is it not coming here, why is it coming to this place and then here? Okay, the n number of reasons I can give. One is, maybe from here to here, the in between some obstacle is there, so direct communication is not possible, so I am making use of the another node, just as an intermediate node to transfer from source to the sink. One reason. Okay, second reason is, this data whatever it is sending may also be required by this node. Okay, and from this node it is easy to send to this sink, so I am using this technique. That is also possible. Okay, or else this may be the controller. Okay, so from this is a node from where actually I'm collecting the data. This may be a controller, because when we say a node, it has to perform many tasks. So if this is the controller, controlling of the data is done here, so the data is sent here, then after processing it is sent to the sink. That scenario is also possible. So like this, we have many scenarios where direct transmission is not possible. Okay, possible is one condition, not possible many conditions. Then this is one more thing. See here, this is the source. Okay, from here this is the sink, but sink in the sense what, this is again this thing, a transceiver. Okay, it is transmitting as well as receiving. It receives from here, then again it connects to the internet, from where actually it can be broadcasted or it can be sent to the many nodes through the wired communication. So that scenario is also possible. Yeah, then comes single hop versus multi hop. Okay, so the word itself tells single hop. Okay, that means a one source to destination, one hop. Okay, versus multi hop, one source, one destination, but it is going through many intermediate nodes, one or more intermediate nodes it is going through. Yeah, some advantages are there in single hop, some advantages are there in multi hop. So you again, there should be a trade off between selecting whether are you going for single hop, are you going for multi hop. Applications for single hop is also there. Okay, exclusively. Applications for multi hop is n number. Okay, application for multi hop is n number. Most of the time we go for multi hop only, but again, exclusive applications I can tell you, just where I have to go for single hop, no other alternate. Okay, if the data is so secured, then maybe some military data which has to be transmitted, then I have to keep a single hop. Okay, in the single hop, again, the frequency, that is a bandwidth, separately we have to keep it for the that particular hop. Hop is like a transmission from one transmitter to receiver, one transmission, that is hop. So one particular band we have to keep. That band cannot be used, though it is free at some times, it cannot be used for some other this thing, commercial use. So single hop can be like that, or wherever actually the data has to be reached very urgently. Okay, the data time, reaching time itself is very important, then we go for single hop. Okay, then you can ask me, if such cases are there, why are we going not going for single hop always? Okay, always a single hop may not be possible, because first of all, it depends on the distance of the transmitter to the receiver. If the distance from the transmitter to the receiver is bit high, then if I am opting single hop, I have to have a very powerful antenna to transmit that signal, so that it has to reach the destination. Because intermediate, I don't have any point to boost the signal. Okay, from the transmitter only side only, I should make enough arrangement to send the signal with high power. If that I can provide, then yes, single hop can be reached. Again, okay, how much ever power we give, the distance matters. If the distance again is beyond some kilometers, okay, hundreds of kilometers, thousands of kilometers, then I cannot go for single hop at all. Okay, that is again, I stress the point in wireless communication only. In wired communication, no. Okay, I can single hop, I can go for 1,000 kilometers also. If exclusive connection is given, I can go. But when I'm talking about wireless, it is not possible for a very high distance between the transmitter and the receiver. So we will be going for multi-hop. Now multi-hop, we have n number of applications. So and it is advantages also. Multi-hop, one thing is my signal power can be less. Okay, the transmitting data transmitting signal power, okay, can be less, because intermediate next to that I am getting the uh, I am getting another node where actually it can be processed, it can be boosted. Okay, then it is the responsibility of the second node to transmit the data to the destination. Okay. Okay. Okay, now here, if I'm considering the intermediate node as the only relay kind, okay, then minimum job what it has to perform is store and forward. Okay, keep in mind, this is just I am telling you to you, we are using the multi hop. In that actually intermediate node will be there. Later on we will come to know that that node itself is another one, another node only. That intermediate node is not only meant for store and forward. Okay, it also can gather data, it also can process, it also can control, it also can route in a different way. So like all those are again included. Okay, that is the actual evolution that is included in the intermediate node. So now what happens in the network, we have many nodes, we have many nodes, all nodes are well equipped. Okay, any process they can do. Okay, any feeble data they can collect. Okay, according to their destination they can route it. Okay, before routing, if it is required to do any kind of changes. Okay, any kind of changes means I can say that power is boosted, I can say that frequency can be changed from the original node, that is the from the source. When it comes to the intermediate node, it would have used the frequency f1. Okay, from the intermediate node, when it goes to the second intermediate node, f1 is not free now. Okay, so it will suddenly is able to shift to f3. So from node 1, that is the intermediate node 1 to 2, it is going at f3. At f3, at node 2, okay, even f3 is not free, it is shifting back to f10. Possible, the destination it is getting at f10. From there actually it is decoded, demodulated, all those things. So that much of work is also possible in the intermediate node. But now actually, initially when we say when we start begin with the multi hop, we say that minimum to minimum it has to do the store and forward task. Okay. uh, Now, what are the basic techniques applied? Now, one is store and forward multi-hop, not the only possible solution. Okay, this is store. That's what I said. Store and not forward is not the only thing it has to do. Collaborative network coding, multicasting, all these should be done. Okay. Now, actually, I had told you the single hop and the multi-hop. Now, if you see, this is the source. See, this is all these are the sync. So the data directly, it is a single hop. Directly, it is connecting to the thing. Check the distance here from the source to the destination. It is not much. Whereas multi-hop, for multi-hop, many reasons are there. Here, one reason taken is in between I have an obstacle. Okay, so the distance is not far. Okay, it is reaching till there is difficult. If you ask me, why can't it go like this? If it has to cross this, I have to put here a very high antenna. Okay, very high antenna I have to put here to cross this like this, and here also very high antenna. So these are practically not possible for the wireless nodes. So we prefer going through a different path. So from here, again it comes here, intermediate comes here, and it reaches this node. This is one of the scenario for the multi-hop network. Anybody? Uh, Somebody wants to say something? Actually, I can get the noise. I can't. I am not like it's not audible to me. Can somebody else tell me if they text? They you can read, right? And I think class CR can do. If the person who is having problem, they can text. Okay, class CR can read that, and he can. Carlton can do that.
No one texted, ma'am.
Nothing is there, right? Then I think somebody must have kept their mic
Continue.
on. Okay, no problem, no problem. We'll continue. Okay, fine. Now, next is multiple things, multiple sources. Okay, the last scenario we have seen single source, multiple things we had seen. Now, multiple thing, multiple sources. Okay, if you see here, see sync. From here, first initially we start from here. From here, it comes here. This is it goes here. So this is what source for something, sync for something. Okay, it comes from here. Okay, then it segregates and goes. So source and sink here. Now this is also it collects from here and it gives to this source and sink. So like that it can we can have that's what I said. Finally, no, now one by one you will study, but finally when you see the complete network, what you will come to know is each node, okay, is not unless it is a sensor. Sensor is just to sense, I agree. After that, when we consider a node, okay, it is not a like it is not a object or a what you call uh, component which will perform a single task. Okay, it has to perform multi task whatever is there, because that those tasks are assigned like prior to the uh, like application, prior to the field, whenever operation, whenever you do. So most of the features, okay, they are trying day by day. If you see, it is the new nodes are coming with the more number of features equipped in it. It has to do the each node has to do. Okay, if you check this, okay, this is actually, see, the data is transmitted to this, okay, and here and here. From here it goes here, then from here it goes to this. Okay, now here if you see similar, okay, from here data is going here. Okay, see, this is bidirectional, goes here again, come, okay, transceiving. Then again it is this mobile is getting from both nodes. This is also not possible. This is there. If you see, if you study your mobile communication, okay, then you will come to know our mobile is continuously receiving the signals from minimum 5 stations. Okay, it will be continuously for 6 seconds. It will be what I call, mm, 1 second, it will be checking which signal has more power. So whichever signal has more power, it will get connected to that tower. So that is the thing. So here also this mobile is getting actually, see, from two signals, from two sources. Okay, so this picture depicts like that only. Okay, 1 to 2, that way. Okay. Now, mobility. When we say wireless sensor network, we can't restrict ourselves for stationary nodes. Okay. Anyway, it is wireless, and application is such that sometimes, okay, most of the times it needs to move around. So, in that case, how are you going to collect the data, transmit and receive the data? That is a challenge. Okay. So, three types of mobilities are categorized. One is the node mobility. Now here the wireless sensor nodes, okay, themselves can be mobile. Yeah, they are. Okay, the meaning of such mobility is high application dependent. However, it is, if you are finding the rainfall at one place, then I don't call that node mobility is required. You keep the sensor at one place, and tomorrow you're telling the rainfall at that place. You don't have to move around and find the rainfall. Okay, but in some cases it has to move, and it has, for example, which can okay, the monitoring sensors, okay, at the border, it will be continuously moving. Okay, if at all you have to monitor some animals, okay, in the forest, okay, or not only in the forest, anywhere, if you have to track any object, that time it will be node will be moving. As the object moves, the node has to move. So in such cases, this comes. Okay, livestock surveillance sensor node attached to cattle. That this is the first example what we have taken in that first class. I had given one example for wireless sensor network, right? So for that, so like this only we can have. In the case of node mobility, the network has to reorganize itself frequently enough to be able to function correctly. Okay, so that is again application specific. Frequently means, that's what I said. For our mobile network, okay, 6 seconds is given. For 6 seconds, once it is connected, it will be connected to one particular base station. Okay, that is suppose a tower, mobile tower, that is suppose tower A. After 6 seconds, so along with that, it is connect also receiving the signal from tower B, C, D, E, F. Okay, theoretically it should be. Practically there may be feeble, very feeble signals from C and D. Okay, but also it is counted that it is connected. After till 6 seconds it will not do anything. Okay, because in the third second, if breeze comes and your this thing, what is that, connection goes off, then still for the rest of the 3 seconds, your mobile won't find another tower, because it is set for 6 seconds. After 6 seconds, okay, it will check the signal strength of the um, remaining 6 uh, base stations. That time it will check. Now it is considered as the base station F is giving the highest signal. Okay, the mobile has come to that region. So because the mobile is moving, right? Cell phone, a person is will be moving. So it has come to that region, and immediately it will get connect to F. It will detach from A, it will connect to F. For the next 6 seconds, it will be in the control of the F mobile tower. So like that it is for the mobile case, I said, mobile phone case, I said. Whereas this is application specific. How do you do? Like whether it is 6 seconds, or you want in milliseconds, or you want in hours. Okay. Next is sync mobility. The information syncs can be mobile. Okay. Now, information syncs can be, what example I can give? See, a patient is stationary. For him, so many sensors they have put. Maybe pressure sensor. That there's so many things. Temperature sensor. They have put on him. He is stationary, but that is connected to doctor's mobile. Okay, but not that. So that becomes a sync now. So he is moving. Okay, so sync mobility, the sync is moving. Now who has to adjust? The stationary source has to adjust, okay, to reach to that. So how it has to adjust? Okay, it may opt the multi hop. Okay, it may opt the single hop. If it is, if the doctor's mobile is within certain region, then single hop is possible. Okay, if he is like beyond that minimum range, sorry, maximum range, then the source has to go for the multi hop. Okay, so multi hop means which all intermediate nodes it has to select. So all these things can be done. Okay. Okay, see, another example is requester can interact with the WSN at one point and complete its interaction before moving on. Okay, that's what using the intermediate node. The requested data of a mobile requester is not locally available but must be retrieved from some remote part of the network. Hence the requester would likely communicate only with nodes in its vicinity which can supply the data. That's what in the example whatever I've given, if you are if you try to relate, it is like the source is trying to reach the destination, okay, sync, but it is not in the range which it can communicate directly. So it will find the nodes in its vicinity so that it will transfer the data to the neighboring node, and the neighboring node will take the responsibility of transmitting it further. Okay. If you see this diagram, uh, where am I? Okay. Now this is the request given. Okay. So request is given to this one. This is now intermediate data. Now this request has sent to these two. Okay. This request has sent to these two nodes. Now this mobile is moving in this direction. These two are simply nodes. Okay, these two are the simply nodes in the network. This is now network. One thing I don't know whether you are aware of it. In the network, every time all the nodes need not work, need not operate. I repeat, in a network, every node in all time need not in the active condition. Whenever its task comes, okay, then only it has to come to the active mode. Otherwise it can be in the passive mode, or last class we have studied sleep mode. So many sleep modes were there, right? So it can go to that state. So these two are now not in action. uh, Once this request is what you call it is request is considered, okay, this it had sent, the request was passed on to this. Now this is sending the response, this is sending the response. Those responses are sent is sent here, okay, because the mobile has moved to this place already by the time the response came. Okay, so this collective response is moved to this. Now this is the intermediate node. Now this is also the intermediate node. Okay, this is the intermediate node now. Okay, from this it is coming to this intermediate node. This mobile is in the vicinity of this node, so this is sending the information or a response to this mobile. Okay, so in this way, if the request, this is now the request, if it is this thing moving, okay, then actually how it can be taken, as and when. Now if the mobile, instead of moving this way, if it would have moved in this way and the response is here, this would have given directly to this mobile, this would have sent here, and from here it would have come to the mobile. So it depends on actually uh, where the mobile moves, okay, your sync moves. Okay, next is event mobility. Okay, in application like event detection, okay, in a particular, in this is like event is any object you can take. Okay, any object. Now as I said, you have put a sensor to an animal. Okay, that animal actually it is moving. Now you are tracking that, so this is now event mobility, that itself is moving, so you are tracking that movement. The cost of events or the objects to be tracked can be mobile. In such scenario, okay, it is important that observed event is covered by a sufficient number of sensors at all time. Okay, uh, more than one sensor should be there for that object. Okay, as the event source moves through the network, it is accompanied by an area of active region. Okay, and that is called as Frisbee model. So this I have said, uh, as per the requirement, it can go to wake up state. Which one nodes can go to wake up state or sleep state? Okay, now if you see here, this is the event or the object which has to be monitored. Okay, so Now it is in this area. So these many nodes are active. Okay, these are in the sleep mode. Got it? Because the object is here. My interest is here. Sensors are connected to this. Okay, sensor is continuously giving the signals to all these. Okay, all these it is giving the data, whatever data wants. Okay, usually it is just the tracking, okay, path in which it is moving. But whatever it is, depending on your application, we cannot restrict only so much. After that, after some time, okay, it has moved to this region. Now these are in the sleep mode. Okay, even including this, these are in the sleep mode. This is the active region. These nodes have become active now. Okay, then you can ask me, what is the synchronization between these nodes and these nodes? Okay, synchronization has to be there when we are tracking this. Okay, for this purpose, how many nodes have been installed, synchronization should be there. Who does the synchronization? Okay, it can be a controller at the remote place, or okay, each one can be a controller. Each one node, you can make it as a controller, that is also possible. Or if you want these nodes to be very simple, okay, then you can send the collected data to one controller somewhere at the remote place, and there the controlling takes place. That is also possible. Okay, next is optimization goals and figures of merit. Now, optimization goals is, I have used these words many times. Okay, optimization is not maximizing. I repeat, it is not maximizing. It is almost like a trade off. You are balancing between, because we have many parameters. Okay, yes, if you ask me to do a very to design a very fine node, okay, which all you think of a application, you think of an feature that has to be there in the node, yes, we can do that. But what about the cost? Okay, are we able to bear the cost? So cost is also a main parameter which need to be considered. Okay, then how frequently we can change that? Okay, how frequently we can upgrade that? Upgrade that, that is also important. Okay, today the application was required application is something, tomorrow the required application is not same as yesterday's, but bit changed from yesterday's. Okay, bit changed from yesterday's. So in that case, it has to be upgraded. So how is it feasible to do? Or see, directly I cannot say, yeah, discard the yesterday's node, today you install new node. No, that we cannot do. So a trade-off should be there. So with those trade-offs, whatever you go for the best result, right, that is called as optimization. Okay, there is a difference in the word maximization and optimization. Okay, maximizing is simply like the one parameter you consider, your priority is only that parameter, and you are maximizing it. That is, for some cases, yes, I can't for that parameter I cannot compromise anything. You ask me any cost, I am ready to give. Okay, you ask me any number of nodes, I am ready to give. So like that it is. Okay, that is maximizing. Optimizing is, as I said, it is trade-off and figure of merit. Okay, so in this QoS comes one parameter are made especially in the context of multimedia application. Okay, it is regarded as low level attribute. Okay, few are, which are bandwidth, delay, jitter, okay, packet loss rate. Okay, or we can have high level attributes. Okay, it is like user observabilities, subjective attribute like perceived quality of voice communication or a video communication. Okay, that means what priority we are giving. This is low level attribute, bandwidth, delay. Now packet loss rate, am I not giving importance to it? Okay, yes, I need to check if out of 1,000 packets, if I miss one packet, then I think I need not worry on that. Okay, in 10 packets, if I miss one packet, yes, I need to worry. Okay, my quality of service I need to reconfigure once again, because that is not acceptable. Okay, out of 10 only 9 is received, one is lost. Okay, so that is also packet loss. When we say packet loss rate, how ratio comes over there, okay, how much it is. And voice communication and video transmission, if the quality is not good, then actually uh, we need to reconfigure it once again. Okay, low level are justifiable, high level are, as I said, are not easy uh, for WSN, so we need to give more care for that. Okay, next is event detection. Okay, then reporting probability. What is the probability that an event that actually occurred is not detected, or more precisely not reported to an information sink? Okay, see, actually this is interesting. Event detection and reporting probability, that means I have put the node to capture one event. Okay, to capture one event. That event has occurred, but the sensor failed to catch it. The event has occurred, the sensor failed to catch it. So that I should see how many times that happened. How many now? Okay, the in the elephant case, a elephant was like was supposed to, like an elephant will be there in the forest. So it certain area is given to it, it should be within that area. Okay, the sensor should give the alarm. Okay, when that elephant is about to cross that border and comes to the next region, maybe that is the village area or something like that, it should give the alarm. Okay, now elephant is crossing the border, but the sensor is unable to, like, it failed, unable in the sense it failed to give the alarm. So how many times it has happened? Among 100 times when the elephant tried to cross, once if the alarm fails, okay, maybe acceptable. Okay, some cases even that is not acceptable. Okay, accuracy need to be maintained depending on the seriousness of the application. Okay, some cases it can be. Now sometimes okay, sometimes another scenario is it has detected, okay, that it is crossing, elephant is crossing, that part it has detected, but it did not, the alarm did not ring. It has detected, the data is there in that, but the alarm did not ring. Even that is also considered as the failure only. So that count we need to take. Okay, next probability depends on trade-off, as I said. Okay, this word it is not traded, it is trade-off. Okay, uh, this word I have used many times, so you all know henceforth, because this in this communication, maybe in other sectors also, I don't know, this word comes a lot. Okay, we cannot maximize any one thing other than that application is so specific. Okay, it is a trade-off only. Okay, against the overhead spent in setting up structures in the network that support the reporting of such an event. Okay, that means what? We have used okay, we have maybe spent 10 lakhs to put that uh, uh, nodes. Okay, 10 lakhs to put the sensor nodes in that forest region, so that to safeguard the lives of the village. Okay, but in that 50 times it has failed. Okay, in 1 month, or okay, yeah, in 1 month 50 times it has failed to detect the crossing of the border. So the elephant has come and actually it has maybe taken life or whatever it is. Okay, which we did not want to happen, that has happened. So we have to see, okay, after investing so much, if such overhead is spent, if this is the case, then what changes we can make. Next, event classification error. Okay, if events are not only to be detected but also to be classified, the error in classification must be small. Okay, in the sense, uh, like different kind of alarming okay, for example, different kind of alarming. Now maybe it may show yellow light for a little bit danger level of something. Okay, some parameter, and red light for high danger. Okay, so that every people in that area has to vacate. Okay, maybe some toxic gases, leakage of toxic gases, something like that. In that case, okay, is for the moderate level, instead of giving the yellow light, if it gives the red light only, then every time the people will be vacating the places. Okay, which is not required because the level was not so high. So such error, okay, that is the it has diagnosed, but the classification error was there. Okay, so that is also not acceptable to certain extent. Huh. Event detection delay. Okay, delay between detecting an event and reporting. Okay, so that is also, you know, that some cases it can't be it immediately when it is detected. Okay, the heartbeat variation of the patient, okay, it has to be immediately reported to the wherever nurse mobile, doctor's mobile, or alarm, whatever it is. Okay, however you have designed, it has that it should have come. Okay, but it has detected, but reporting it is making delay. Okay, so the patient is suffering now. Okay, he is not being attended by anybody, so that is the problem that also have to be taken care. Okay, all these, no, whatever optimizing parameters you have to feature, you have to take care. I repeat, for all applications all these things are not required. Sometimes delay can be okay. Okay, if you have just for 24 hours, once 24 hours, if you are finding the rainfall rain yeah rainfall, how much it is, in that case, if you tell me, okay, yes, since yesterday, and from yesterday today 10 seconds delay was there, it is not going to affect much. Okay, that is agreeable. Okay, that is acceptable. That's what, depending on the application, we have to see, we have to prioritize our optimizing features. Okay, now next one is missing reports. In applications that require periodic reporting, the probability of undelivered reports should be small. Okay, tracking accuracy. Tracking applications must not miss an object to be tracked. Okay, the reported position should be as close to the real position as possible, and the error should be small. Okay, okay, next is energy efficiency. Energy is a precious resource, we have discussed many times, and that energy efficiency should be therefore given priority in optimization of your complete network. Okay, energy per correctly received bit, how much energy, okay, counting all sources of energy consumption at all possible intermediate hops, is spent on average to transport one bit of information from the source to the destination. Okay, this is actually your uh, what is this budget. Okay, power budget you are doing, this is one major area which has to be look into. Okay, power budget, not the cost budget. Cost budget comes later. Sometimes cost budget is easier compared to power budget. Power budget is, see, from node A I have to send to node B, but in between that I have a huge hill, like how I have shown. So it has to pass through node C, D, E, and then B. Intermediate three nodes I am using. Okay, when I'm using three nodes, the cost of three nodes, okay, cost in the sense, uh, it has to receive this from node A, it has to process. For that, energy is required, right? Whose energy? Node C's energy is utilizing for that, is being utilized for that. If I could transmit A to B directly, then C would have spent that energy for some other purpose. Now, just to transmit from A to B, okay, C is utilizing some power, Okay, C is sending, D is utilizing some of its power. So that is power budget calculation. How much? Okay, just to transmit one bit, if we are using too much of power, then actually we need to check, okay, any other alternate is possible. That is actually power efficiency calculation. Okay. En- Energy per reported event. Average energy spent to report one event. Okay, just to see, capturing the event is different, energy spent on that is different. Reporting that event, okay, that data to the next node is different. So how much energy you are spending on it? Since the same event is sometimes reported from various sources, it is usual to normalize this metric to only the unique events. Yeah, sometimes we say that, but it is not possible, because accuracy is required. Now only see, you people say network issues where we don't get the connection. Okay, why is that, right? We don't get the connection because it is though theoretically I say that six for your mobile, six what is that, towers are connected. In that, few are not sending or transmitting clearly. If the mobile is quite far off, okay, it will not do that to save the power. To save every seconds, if you're if the tower is sending the signal, then the signal, I mean, power of the tower is wasted. So it won't do that. But if you are able to normalize, then actually it is okay. But this is a big, actually, this is a very big area which need to be looked into. What is our priority? Is it a like a continuous uninterrupted communication, or is it energy efficient? So based on that, actually, we can do the trade-off. Then next is delay energy trade-off. Okay, some applications have a notion of urgent events which can justify an increased energy investment for a speedy reporting of such event. This actually prioritized. Okay, if at all this one particular condition happens, then leave all the other parameters aside. Okay, go for this. Okay, spend the complete energy on sending this data with high whatever it is. Okay, high power or whatever it is. If that's what the pulse rate of the patient goes very high beyond some threshold level, then it has to be reported immediately at any cost. So in that case, leave all the other parameters aside and take care of this. Okay, so some more topics are there. I will discuss this in the next class. Now, listen carefully. I need to talk about your internals. Okay, since both the sections are there, later you can communicate this to your friends, those who are not there, or actually they ask them to see the video. Now you are having a test for 1 hour. Okay, 9:30 to 10:30 in the morning. Similarly, afternoon. Now 9:50 link will be sent to you by the invigilator. Okay, so 9:15 you have to log in. Now 9:15 only question paper will be displayed on the screen. So 9:15 to 9:30 you need to copy down the question. Okay, 9:15 to 9:30 or any time. Okay, that depends on you. But you complete writing the questions in the one go itself. Later on, again you have to unmute, have to ask the invigilator to scroll down, scroll up. So all those things you need to do. Instead of that, it is better. Okay, you finish off writing the questions. You have to use the A4 sheet. Okay, yesterday we have sent the notice. In that you might have read it. A4 sheet. In each sheet, you need to write your name and USN, subject name and code. Okay, your name, USN. You can write down those if you want. Okay, then subject name and subject code. This much you have to write down. Then once you finish 9:15 only you are starting. You don't tell that okay it was 9:30. 9:30 is the answer writing time. If you are comfortable enough, to just see the question on the screen and write the answer in 1 hour, then log in at 9:30. After 9:30, you are not allowed to log in. But those who want enough time, you can log in at 9:15 only. The question paper will be displayed at 9:15. So 9:30 to 10:30 is the writing time. Okay, 10:30 you are supposed to stop and scan that. Okay, so after scanning, you have to make one single PDF and then upload it in the given link. Okay, so that should get over by 10:40 or so. I think 10:40 or 45, 10 minutes should be sufficient. Okay, so please be true to yourself. You are in a final year. Next year, by you are attending your placements. By next year, you will be okay. Hopefully, we want to see you in placed companies. There actually nobody is there to preach you for your ethics and all. So and overnight you don't get that. Okay, mind it, overnight you don't get that. So you need to practice. So from now only it is better, okay, be true to yourself. And yes, we will be invigilating. Okay, how much ever from our side we can do, we are doing it. Okay, we will ask you to keep the cameras, mic on. Okay, by default it should be on. And if you have any internet issue, that is your problem, because HOD has given the permission for the students to come to the college and use the college facility to write. Okay, so those who have a really genuine problem, you can come, because nowadays everything is unlocked. So you can come to the college and you can write here also. Get your mobile, okay, to scan and all, that will be easier if you are coming to the college. Invigilation is done here also, no problem. Then you have to scan and upload. Offline means coming to college means it is not offline, it is online only. uh, okay, so camera and all should be on, and you write for 1 hour. For you people it is 30 marks. Okay, and particularly see, next what I am saying is exclusively for my subject. Okay, 30 mark is common for all final year subjects. Now in my paper, okay, two modules, first two modules are included. First module and second module is included. Now I am giving two parts, part A and part B. Okay, part A, 3 questions. Those who are writing, you can write down. Part A, 3 questions, 8 marks each. You have to write two. Okay, so you will be getting 16 marks over there. Part B, 3 questions, 7 marks each. You have to write two. Okay, so you will be getting 14 marks there. So 16 and 14, 30 marks. Okay, 16 and 14, 30 marks. So in both the parts, you are getting one choice. Okay, and mine, since there are no problems, you can expect it is a this thing, architecture, all those problems will be there. Now those who have not seen the video, not attended the class, okay, I have told you many times, it is your this thing, you have to do it. Question cannot be very direct. Okay, question may not be very direct, underline that point. And I had asked you to write the assignment, right? Many times, okay, in the PPT also it was there. Okay, this is an assignment. This is an assignment. So I had asked you 2-3 times to maintain a book in that write and keep. Now actually I will be giving the date. So in that date, you just take the pic of it and upload it. Okay, those who have not written, I don't know, because I have given enough time and I have warned, or I have just reminded enough number of times. So those who have done it, just I don't need any further modification in that. Just take the pic of it and send it. I will give the date. Okay, I will put it in the canvas. Those who have not done, you have to do it. It is an extra burden for you during your internals. So this is about the internals. Okay, so those 3 days, yeah, those 4 days, even the Monday we won't take the class. It is for you to read. Today, tomorrow is a holiday. Saturday you don't have class, right? Saturday is your project thing. Sunday you are free. Monday there is no class. Tuesday, Wednesday, Thursday you have internals. Okay, so this was my class before the internal, so I thought I must tell you this. So be true to yourself, and while writing, please, since see, even we have our own limitations. Anything you scribble, if you expect us to read, please, I will not read. Okay, then later don't question me, why didn't you give? I cannot read. Now only I will tell you. You cannot expect me to read anything you scribble, because I am not seeing the direct paper. Hard copy is not there with me. I am seeing it on the laptop. So if it is not readable condition, I don't know. Like how I correct my VTU paper. Sometimes I give just half mark if I feel that okay, some diagrams are there. Okay, a half mark. Sometimes I give directly 0. So same thing will be continued here also. If it is a real hard copy blue book, yes, you can come and ask, okay, ma'am, I have written this and all, that should be okay. But here actually now that condition is not there, so it is your responsibility to write, okay, far, use enough number of A4 sheets, okay, keep a distance between the sentences, space between the sentences, and write neatly. That is, you're in final year, you should be knowing it. Okay, fine. Now I'll give the time for you all to unmute and ask me the questions. Yeah. Anybody? Any question? Or you can put it in the chat box also. If you don't feel like this thing, you can put it in the chat
Hello,
box.
ma'am.
Who's that?
Ma'am Sagar.
Sudvika?
Sagar.
Sagar, Sagar. Tell me, tell me.
Ma'am, in
Uh,
the today's class, you said
uh, you
the
have doubt, okay.
communication,
uh,
that communication we have to direct it through various different towers to reach the sink. In case direct connection to the sink is not possible.
yes.
So if we have to do a real time projects which requires a real time processing in the cloud, or not only just sending the data, then is it feasible to use an IoT in a highly
Yes,
real
you
time
need.
intensive task? Like we cannot wait for more than 3 millisecond delay. In those kind of cases is it better to rely on this, or should we have onboard processing wherever we need the results?
See, if your application is sending the data to some place, then whether you do onboard processing or directly send the data and expect put the data in the cloud and there you process whatever it is, okay, the data has to be sent now. My this thing was, explanation was on sending the data. Okay, that 3 seconds you said, no, you are to send. See, if you send the unprocessed data also, you want that to reach in 3 seconds. If you are sending the processed data also, you want to expect to reach that in the 3 seconds. Correct, no?
Yes, ma'am.
Sagar?
Yes.
Then it is like whatever type of data you do, if you're relying on the cloud computing, then actually you can't completely say that yes, my network is 100% this thing. Okay, I get very fast. No, because now whatever you're seeing, whatever you're facing, okay, you can see Sagar left, Sagar joined, Sagar left, Sagar joined. Why that is happening? Because your network is like you're joining your this thing, Google Meet, you're leaving the Google Meet because of your network this thing, what is that, uh, network problem, not like you don't have the proper communication. So same thing, exactly same thing is going to happen. I'll tell you, once we are into wireless communication, we cannot guarantee that yes, now the communication will be perfect. For this afternoon 12 o'clock to 1 o'clock, I will not have any disturbance. I will be getting a clear cut communication. That is not possible. Okay, whether it is an IoT application or any this thing. And what you said, it doesn't come here at all, processed or unprocessed. That is like you think how, where do you want the complexity? Okay, in the remote area where you keep your IoT, this thing, no, sensor node, there only, if that is able to bear the system complexity, you do the processing there only, no problem. But later,
Yeah.
what you are going to do? You are going to send the data. Ah, I am talking about sending the data. I am
Yeah.
talking about sending the data. Sending the data, we cannot guarantee. But okay, now you see, so much of communication is happening. We can see whether you're going for a wired communication. Wired communication is quite better compared to wireless
Yeah.
in many cases. Okay,
Yeah.
if you ask me, but if you Google, they will tell that wireless communication is better because it can reach any places. That one thing is which is highlighted. Wireless reaches any places. Okay, yes,
Yeah.
I agree. But wired communication is much more secured as well as what is guaranteed,
Hmm.
guaranteed compared to it. So communication wise, we cannot give any guarantee that okay, this is very high priority, this thing. So uninterrupted, no, I doubt. We can't
Okay.
guarantee that.
Should we have a dedicated broadband for these applications in order
Yeah,
to
yeah. If
make
you
it
have,
more real time?
yeah. You can have a dedicated, provided like dedicated, you should get no
Yeah.
dedicated frequency band. You should get right.
Yeah.
That is difficult.
Yeah. Like,
All frequency band, all are actually.
are there
Tell
any
me.
service based, cloud or any softwares which gives us this flexibility, or which uses private broadbands
Mm,
for projects and all? Is
Uh,
there any?
no. About dedicated path, if you are asking, as far as my knowledge goes, no, this thing gives you that. Okay, platform gives you that. If later you can Google, as far as I know, that 2.4 gigahertz band is there, right?
Yeah.
That across that, to any of the application runs in that only. That is actually free, used for your these small projects, all those things. That is free. Your hotspot also comes in that only.
Yeah.
Okay, 4 gigahertz. So that only you have to use.
Yeah.
Otherwise, only for like government or military or something like that only, dedicated band will be given.
Yeah.
Okay,
Okay.
now
Okay.
these edusats and all are there, no,
Yeah.
government, all
Yeah.
those will get dedicated path,
Yeah.
uninterrupted dedicated path like that.
Yeah.
Otherwise, I doubt.
Okay. Okay.
Okay, if I come to know
Yeah.
anything like that, I will let you know later.
Yeah.
Okay.
Okay, ma'am. And about
Okay.
exam, ma'am, is it necessary to unmute, because surrounding noise will add, and if everyone has any noise around, then it will distract while writing.
See, actually, now as per the notice, you have to unmute. Okay, and you have an invigilator. Once you log in, you can request them whether can we mute only the mic, or even they may say, it depends on the invigilator. Okay,
Okay.
this thing, video should be compulsorily on.
Yeah.
Mic, you just inquire, I mean, what invigilator. If they agree,
Okay.
you can do that. Okay.
Okay. Okay.
Hmm. Yeah.
Thank you, ma'am.
Yeah. Any other doubt? Okay. Anybody else? Any other doubt regarding the topic? I forgot to ask regarding the topic, or regarding the test.
Ma'am, usually we
Take the
have the
test.
hello,
Uh,
hello. Good morning,
tell me, Hitesh. Yeah. Good
ma'am.
morning. Yeah.
Usually we have the
Uh,
test for 1 hour 15 minutes, no, ma'am. Like, and this is like
uh,
theory subjects. So why
uh,
is it restricted to 1 hour this time?
Restricted to 1 hour. Actually, it is now extended. See, 9:15 only it starts.
Like,
Okay, you don't need 15 minutes to write.
so okay, ma'am. 9:15 we can start writing the answers also in that
Yeah.
sense. Okay, ma'am.
Yeah. That's what I said. The notice says that 9 only you can start. When you get in, the question paper will be displayed and you can start all this thing. If any issues are there from the invigilated side, they may give you the extra time also.
Okay, okay.
You will be having enough time.
Okay.
It is actually 1 hour 15 minutes or 1 hour 30 minutes we could have kept, but for your sake only, per day 2 times you have to write your data pack, okay, your data, whatever it is.
Yes, ma'am.
From student side only, it was this thing, so it is restricted to 1 hour.
Okay, ma'am. Thank you.
Okay. Okay. Anybody else? Anybody else? Okay, I don't find anyone. Fine. Okay, so for this week, this is the last class, and next week we have internals. Hopefully, I will see you next to next week in offline mode. That is, we expect you in the college. We'll see what will happen. Okay, thank you. All the best, boys.